Curvilinear coordinate systems 10. A tokamak fusion device has a geometry that takes the shape of a donut or torus. Calculations for such a device are sometimes done with the toroidal coordinates shown in the figure r, theta, and phi with respect to the x-axis. The major axis of the device is a vertical straight line that forms the toroidal axis of symmetry. The minor axis is a circle of fixed radius r0 that passes through the center of the donut. The position of a point is described by the coordinates r, theta, and phi. The coordinates r and theta are similar to a two-dimensional polar system aligned perpendicular to the minor axis. The coordinate phi measures the angular position along the minor axis. So we have already sketched the unit basis vectors, found that this is a right-handed coordinate system. We obtained the transformation equations between toroidal and Cartesian coordinates. Now in part C, obtain HI, the scale factors for the toroidal system. Okay, so how do I obtain the scale factors? First of all, I have to write the position vector r, and in Cartesian coordinate systems, the position vector is given by x, ex hat, plus y, ey hat, plus z, ez hat. And now I know the coordinate transformation equations. So for x, I'm going to substitute r0 minus r cosine theta cosine phi in ex hat direction. And for y, I'm going to substitute r0 minus r cosine theta sine phi in ey hat direction. And for z, I'm going to substitute r sine theta, because theta is the angle with respect to the xy plane, in ez hat direction. Now I have to take the partial derivative of the position vector with respect to r, del r, and you can see there is no r here, so this will give me minus cosine theta minus cosine theta cosine phi in ex hat direction. This derivative will give me minus cosine theta sine phi in ey hat direction. And the last one will give me sine theta in ez hat direction. Now, what is the corresponding scale factor, h sub r? It's the magnitude of the partial derivative of the position vector with respect to r. Let's find this magnitude. Now you can see that it's cosine square theta, cosine square phi, cosine square theta, sine square phi. So it is cosine square theta parentheses cosine square phi plus sine square phi. And then I have sine square theta plus sine square theta, and this is all inside the square root, and cosine square plus sine square is equal to 1, so this is 1. Then I will obtain cosine square plus sine square again, which is again 1. Therefore, this is 1. Therefore, the scale factor h sub r is equal to 1. Now I need to take a partial derivative of r with respect to theta, the position vector r with respect to theta, the angle theta. Here I have theta here, so it's cosine theta. That gives me minus sine theta. So this will be r sine theta cosine phi in EX hat direction. And here I have the same thing, R sine theta, once again for the derivative of minus cosine theta, and sine phi in EY hat direction. And for r sine theta, the derivative is r cosine theta, derivative with respect to theta. So this gives us r cosine theta EZ hat. The corresponding scale factor h sub theta is the magnitude of the partial derivative of the position vector r with respect to theta, the coordinate theta, and that will give me, because all terms have r in them, r is common, r, then I have sine square theta in the first two terms, so it's sine square theta parentheses cosine square phi plus sine square phi and then I have cosine square theta, and this is all inside the square root except r. And similarly, cosine square plus sine square is equal to 1 here, and I obtain again cosine square plus sine square, which is 1. Therefore, the scale factor is r. So h sub theta is equal to r. And let's work on phi now. I'm going to take a derivative of the position vector r with respect to the coordinate phi. Okay. There is no phi on this one, so no derivative from this part. This one will give me sine phi minus sine phi, and this one will give me plus cosine phi derivative. So let's see. So I'm taking the derivative with respect to phi here. No contribution from this one. This gives me minus sine phi. So it's going to be r cosine theta sine phi EX hat, the first term. And this will be minus r cosine theta cosine phi EY hat, because the derivative of sine phi is cosine phi. All right. So del r del phi is r cosine theta sine phi EX hat and minus r cosine theta cosine phi EY hat. Okay. Now to find the scale factor, I have to look at the magnitude of this vector, magnitude of del r del phi Here I have a common term, r cosine theta. So it's r cosine theta parentheses sine square phi plus cosine square phi square root, and sine square plus cosine square is again equal to 1. So this gives me the scale factor h sub phi to be r cosine theta. All right. So we were asked to find the scale factors. And first I have written the position vector using the transformations between toroidal and Cartesian coordinates. For x, I substitute r0 minus r cosine theta, parentheses cosine phi. Y, parentheses sine phi, and z is r sine theta. Derivative with respect to r gives me minus cosine theta cosine phi ex hat minus cosine theta sine phi ey hat and sine theta ez hat. Derivative with respect to theta gives me plus r sine theta cosine phi ex hat plus r sine theta sine phi ey hat plus r cosine theta ez hat. Derivative of sine is cosine. And derivative with respect to phi gives me plus r cosine theta sine phi ex hat and minus r cosine theta cosine phi ey hat. There is no phi on this term. Okay, and then we take the magnitudes. Square root of x component squared plus y component squared plus z component squared. This operation gives me for the scale factor r 1 because for the partial derivative here I don't have any r, and the square root of cosine squared theta cosine squared phi plus cosine squared theta sine squared phi plus sine squared theta cosine squared theta parentheses, this is 1, and the square root of cosine squared plus sine squared is once again 1. For del r del theta, this one, I have r squared sine squared theta cosine squared phi, r squared sine squared theta sine squared phi, r squared cosine squared theta. R squared comes out of the square root, sine squared theta parentheses cosine squared plus sine squared plus cosine squared. Once again, in the square root I have 1, so the scale factor is r. And for phi, I have r cosine theta is the common term. Square root of sine squared plus cosine squared is 1. So this gives me, once again, r cosine theta for my scale factor.